Holy cow, we're already on section 1.4. Time is flying by. This section is going to probably be a little bit more tedious in the fact that we have a lot of vocabulary words to go over and some demonstrations of what it looks like and so forth and so forth. Okay, so here we go. So we're talking about angles now, angle measure, angles being the biggest thing, but in order to be able to define what an angle is, we got to be able to identify what a ray is first, okay? So a ray, I'm going to read it out loud to you right now, a ray is part of a line. So let's write that down. Part of a line, okay? And the rest of the definition states that it has one endpoint. So has one endpoint and extends infinitely in one direction. Extends infinitely in one direction. Okay. So what I also like to call the endpoint, I like calling it also I'm going to put this in parentheses, starting point, and then and then the other part that I like to sit there and say, the other extends infinitely in the direction has no end. Okay, so it depends on how you look at it, how you want to talk about it, and whatever it may be. Okay, so a good example of a ray looks like something like this. Okay, so you're going to draw a line. So we're going to have a starting point. We'll call this A. And then we'll have a line. And it goes here. And we'll call this B. Okay. Now, how we identify a ray, as far as when we talk about or find the answer of it, it's going to look something along like this. We always start with the starting point. Okay. Whether it's in alphabetical order or not, or whatever direction it points, because this actually could go this direction, opposite direction, and it doesn't matter. Okay, you always start with the starting point. This is the thing. So you're always going to go A, then you put the B, then you draw a line with an arrow over the top, and the arrow goes over the end that has where the arrow is. Okay. Whereas the one that doesn't have, or the starting point, is where you always get. Whether it goes to the pointing to the left or pointing to the right, it's always going to start with the A and then the B second in this scenario. Okay? So now, the next one is talking about opposite rays. We've always sometimes talked about this before in the past, but I mean, I don't know, you should know, but it may be new to you. Okay, the opposite rays basically means that you have a ray, let's it's a ray that goes is what we'll call it a straight angle, okay, or we can also call it a I'm trying to think of the word straight angle, or I can't remember the second one at this point, but let's just think about straight angle and it'll probably come to me. So let's draw a picture of it first. It helps me out. So I'm going to draw a picture. And we have a point here in the middle. We'll call this A. Okay. And then we'll have another line going this way. We'll call this B. And we'll call this one C. So basically what it means is we have rays going in opposite directions, which is a straight angle. Or, I remember the word now, it's called a supplementary angle. Now both of these always equal a total of 180 degrees together, so it's a straight line. Okay, technically it's a straight line or a line that goes in opposite directions, and it's just that we start with the starting point being at A and going that way. So we could label this as, technically we'd go AB, and this one would go AC. Okay, so those are opposite rays. So basically going opposite directions are called either a straight angle or supplementary, and it's just an A that has, you know, starting point that goes in both directions. My hands aren't too big to fit in there, but and I always use that as an option there for you. Okay, so with those definitions being in mind, let's check out what these definitions are. An angle basically is two rays with the same starting point is what I would say, or you can say your end point. Okay. In the book, it says an angle is formed by two non-collinear rays that have a common endpoint. So we can put in here again that they are two non-collinear rays. So two I'll make sure I spell collinear right. Non-collinear rays, not points, that have a common endpoint. So I have a common endpoint. So whatever you decide to do, but that's how I want. I always try to put things in my own words so I understand it better. Okay. So as you see here in this picture, we have a ray, which is this one right here, and these are called, on an angle, this is called a side. Okay. As you can see over here, it's a side, and we can label this as X, Y, with an arrow over the Y. Okay. So our sides are that way too. So that's side one. Okay, and we can call this also a side in green. We'll call this a side, and we'll call this one, again starting with the endpoint, X, and then the Z is the arrow side of it, and we'll go this way. And even though the arrow's pointing to the left, we're still going to do it that way. Okay, so they're the sides. So basically, we can sit there and say that they are rays. Okay, vertex. What is a vertex? Vertex is basically the endpoint or starting point of the two rays. That's one way to do it. Vertex, and here it says the common endpoint is a vertex according to the book. Okay, so we're going to sit there and call this the vertex. There's no really one way to say it or label it like we do up here with the rays on this whole thing, but we're just going to call this one our endpoint or our center. Okay, now naming the angle. This is interesting because the vertex, you have to have all three letters. Okay, so let's move this up a little bit. We have all three letters that need to be identified, and the vertex always goes in the middle. Okay, so it can be labeled two different ways. So we're going to sit there and we have a symbol. Looks like a less than symbol, right? Then we're going to go Z, which is this point. Then the vertex goes in the middle, and I'm going to underline that. And then we're going to put the other one Y over here. So that's angle ZXY. Or we can label it as the other direction where we go Y, X, and then Z. Okay? So that's how you name the angle. So that's the symbol we use, and then we give the three letters. It has to be all three letters in order to be able to do it. Or if we only have one angle that we're identifying, then we can always sit there and say and call it angle X. But if we have multiple rays coming off this one endpoint or starting point, then we would have to use all three letters in order to be able to do that. Okay, but we'll talk about that a little bit more later. All right, so let's go ahead and move down to the next part. See, like I told you, there's going to be a lot of vocabulary stuff here for you. You can go back in the book and look at and get more information. There's some other examples that might be in there. So points on the plane with an angle. Okay, so here's our angle. Let's highlight this in red. Okay, so we have our angle here. And just for practice, we're going to call that angle Q, M, and N. Okay, so we got that. So now, as you can see, there's a shaded darker area and then a lighter shaded area. What we're going to identify is that there are things that are on. We're going to be interior and exterior are the things we're going to talk about. So interior, on means anything that lies on the line. Okay, so in this case, we look at what points lie on the line. We're going to talk about, okay, Q lies on the line, M lies on the line, and N lies on the line. Okay, now interior, what it basically means is whatever's on the inside of the angle. So we drew in red here, and if I were to extend this all the way out, we could do that, and we could extend it out that way. So we're talking about this area, darker shaded area is called the interior. Okay, so that means this lighter shaded area on the outside is called the exterior. So all you're going to be doing is identifying which points are on the inside and which ones are on the outside. So in this case, what we would identify as only S and R. Now, a common mistake that a lot of people make is that they'll use also these letters that are on the line as considered to be interior or even exterior in this case. Now, the ones that are on the exterior, we have some out here, which would be P, M, and O. Okay? Any questions on that part? Okay, so let's go ahead and I'm going to look at the next page here, see where we're at. If not, we're going to continue to go on here. Yep, we're going to sit there and go on this part. And here we go. Let's move down. Now we got to talk about streets. So we're going to apply this to some real life stuff. We got a couple minutes or 3 minutes before this segment ends, before we stop. Okay, let's check this out. Let's go here. It says, use the map of a high school shown to answer the following questions. So here's our map. As you can see, there's angles inside here. Now notice we didn't talk about this before. Oops, I've got to go back up. I made a mistake and forgot something. Okay, now the other part we could do too in this scenario is notice that there's a number inside this angle. That means I always label, you can mark it with an arc. We can also label this as a angle 3. Okay, so as we go down here again and we look at that, okay, here's our angles. 1, 2, 3, 4, 5, 6, 7, and stuff like that too. And then we have all our intersections labeled with our letters. Okay, so it says name all the angles at B that has B as a vertex. So here's B, it has a vertex. So we need how many letters? We need 2 rays. So here we go here to here. So we'd sit there and go angle A, B, and D. Okay, we could also go A. Well, is there any other vertex that comes off of this? We couldn't go any further. Maybe that would be the only one that we can see. What do you guys think? We can also label this as what? Angle 1. Okay. What about over here? Oh, here we go. How about this? D and B. So that we got here, we got this. So we got angle D, B, and C. Or we could go D, B, and D, B, and K, or angle D, B, and L, or we could sit there and call this angle 2. Okay? We're okay with that so far? So there's a lot of different things here. So we have this here, so we got the angle going this way, and then we have the angle going that way. Now name the sides of angle 3. So here's angle 3, so we only need 2 sides. So we got, so again, we have our vertex of angle 3, which is going to be C. So we can sit there and go, okay, we want ray CE, which goes this direction. And then we can go, again, vertex C to B. Or we could go C all the way up to A for that one, and we'd label it that way. Okay? Another angle, name of the angle of G. Here's G, H, and L. So here we go. So we look at this. You got this arc in here. This is going to be an angle 7. Or we could do the opposite direction, which would be angle L, H, G if you wanted to. Okay? And then lastly, we want to name a point on the interior of D, D, B, K. D, B, K, and the only one we can see up here would be